First of all, I'm glad to say hi to all of you here in our nice building. And I would like to say thank you for organizers for having me here and you guys for coming. So what's our topic today? Pretty long name, I know, but it's about unlocking the modern React Native's true potential using turbo modules, GSI, and cross-platform multithreading with C++. I know it sounds a bit frustrating. That's why I included a quote here, my lovely one from Einstein. It says that if you can't explain it to a 6-year-old, so you don't understand it yourself. And yeah, I'm pretty glad that there is no 6-year-old here. It will be really tough, but nevertheless, it means that if you can't get anything, just stop me, ask questions, and it's probably my issue if I can't get it right. So shortly about me. I'm Anday Ismayilzada. I'm originally from Azerbaijan. I completed both my degrees in computer science, and currently I have over 5 years of professional experience in React Native, and currently working here at JP Morgan Chase as a senior React Native engineer. Also, I enjoy doing some open source libraries. One of them is React Native OTP entry, and that's basically a simple OTP input that you can use for one-time passwords in your apps. Currently, it's around 63,000 downloads per month, so you can help me to increase that. But let's get into the agenda. So we'll start by looking at the old and new architectures, the differences, and later we'll switch like to more related to my topic stuff like GSI and turbo modules. Then we'll look at the demo project that I prepared for the sake of presentation, all the capabilities that we'll see throughout this slide. And we'll go through that configuration and development part. And at the end, I prepared the section for demo and results. And we'll have one additional bonus slide where we will discuss like real-world scenarios of this. So yeah, let's start with architectures. I'll do a quick recap. I know all of you familiar with old architectures and maybe also with new architecture. So as a quick recap, in all architectures, what we had, as you may see that the main part of it is that bridge, that big rectangle in the middle. And it kind of holds the main idea of React Native, that communicating between those JS world and the native world was connecting them. But it was connecting them in a way that serializing all the interactions between those worlds to the JSON. And it was causing some latencies because all this process was async, and you don't really know what to expect. There was no awareness between those two realms, let's say, because everything is getting serialized and there is no awareness. And if you want to have something, let's say CPU bounded or accessing some device-specific APIs, you will probably need to use native modules for that. They were working fine, but still you have that overhead with JSON serialization. And these issues, this bridge issue, mainly addressed in the new architecture, where we have some new components like GSI, CodeGen, turbo modules, Fabric. So let's start with GSI, because GSI here is a main actor that solved that issue that we had with bridge. So it basically solves in a way that it's written in C++ and it kind of holds the memory addresses of the things. And you can send data over those you can communicate between JS and native side by using memory addresses. And those memory addresses are pointing to C++ objects, host objects that kind of helps you to move that data without any serialization. And this GSI means JavaScript interface that can basically plug in any JS engine, let's say, this V8 Hermes, if it like implements that interface, you can plug it in and use it. So you can even use your own engine for that. And that CodeGen with turbo modules. So CodeGen came pretty handy in the terms of, as I said previously, we didn't have any awareness between the JS side and the native side. So CodeGen basically picks your interface that you wrote on TypeScript side, on JavaScript side, and generates a boilerplate native code on the native side. So you don't need to manually write all those types, write the boilerplate code. So CodeGen takes over these things. And if we quickly mention about Fabric and Turbo modules, so Turbo modules is sort of solves that breach problem for native modules. So it's communicating, it's kind of native modules, but over the GSI. And the Fabric, on the other hand, it's a new UI layer that replaces old UI manager in a way that it also allows GSI in a synchronous manner access native views. So at this point, we can move closer to our topic and discuss advantages and main features of GSI with turbo modules. So as you can see here, I point out some of the features. First two of them I want to combine is direct access to C++ and efficient data handling. So both these features are coming from the point that we are getting rid of breach. That means that we have direct access to C++ functions, to a C++ side, so we can invoke any function there by using that GSI, which, as I said, pointing to the memory itself. And there is no serialization because we don't have breach anymore, and everything is being communicated over the objects, over the C++ objects. So you can now even send data that's not serializable, so which was not possible previously. And also these features unlocks us the threading and parallelism because we now have access to a low-level language. As we know, JavaScript is single-threaded, but because now we can take advantage of that low-level language, C++, we can spawn some threads there and avoid blocking the main thread. That way this JS is running. The next point is about cross-platform consistency. That's the thing I mostly liked about this writing, especially these C++ modules, because now you have a single module, shared code between two platforms. So you are sort of like following that ideology of React Native. So you are writing a single code and you are sharing it as much as possible. And last but not least, it's good to mention that lazy loading also introduced with turbo modules in a way that now not all the modules are getting into the memory right at the startup. So as I said, if we describe this new architecture in one simple sentence, going a part of this, all the advantages, we can say that it brings more awareness between those two worlds, JavaScript and native. So now JavaScript is more aware about the native part, and it can load the code basically from the native part on demand. Cool. I think right now we have enough overview to go to see some details about the demo project that I prepared, and we'll see in the example of this demo project how all these things are working together. So for the sake of demo, I implemented, it's a hashing algorithm, bcrypt hashing, but it's more a state-of-art project. And on the front end, we don't use hashing that much. It's probably more like an extra layer of security if you want in your app. You can add that for communication with backend or storing some data in a hashed form. But apart from that, it's also available in library format, and that library also includes in the repo demo project, so you can use it in both forms. If you have your application that using new architectures, you can just do npm install React Native bcrypt cpp and start using that. And this demo project includes that direct invocation of C++ function from the JS side using this GSI interface, and also implements that multithreading that we will see. Also, in this project, I included pure JavaScript solution of this hashing algorithm, so that we can see the differences between those implementations and see that performance differences. And last point is that it's completely open source. You can go and check it out, the source code on my GitHub. I'll place the link at the end, but just don't do it now because you can get some spoilers for the demo and results part. So let's quickly go through configuration. It's also important. We use Turbo modules, but I'll try to keep it short and move to the development part. So the first step that you need to do with Turbo modules, it doesn't really depend if you are doing it for C++ or for each platform natively. You are coming up with JavaScript specifications. To be precise, TypeScript specifications, because there's no meaning writing types. Like you cannot do it on JavaScript. So that's being written for the sake of CodeGen to pick them up and generate a native code, as we mentioned before, for you, all the boilerplate code. So as you can see here, we are defining 4 functions. 2 of them are synchronous. The other 2 are asynchronous, and they do implement that non-blocking strategy. And we'll see that all this code will be generated on the native side and will be like ready and waiting us just to come and fill that brackets between those functions on the C++ side. So it ensures our type safety at the build level, that new CodeGen. And it's kind of sort of contract, just to be sure that we are aligned between the JavaScript side and the native side. After doing that, and it's pretty cool that it really aligns with the software engineering strategy. Like when we want to implement something in our app, we first come up with the specifications. So it also aligns with that process. And one small piece of work that we need to do before moving to development is to register that C++ module for each platform, because it's kind of, we are loading that module. Here's a snapshot of that code. You can check it later, but it's an objective C++ code. What it basically does, it just loads our Turbo module into the global module map. It's kind of like saying to the React Native side, to a JavaScript side, where to find our module on the iOS side. For Android side, it's a bit tricky, but not much. As you can see here also, we mainly use boilerplate code, and we have 2 files there. One is React Native config, where we again specify the name of the module and the name of the CMake file. So CMake file here on Android side, linking C++ code to Java is a bit more tricky than linking to Objective-C, because it just consumes it natively. But still, you can overcome this by writing a simple CMake list. And the code there is pretty common boilerplate. You are just defining the version of the C++ you are using. You are defining what libraries should be linked, like GSI, CodeGen, and etc. So if you just take it once, and you can use in all your modules. So that's again boilerplate. So now we move to a more exciting part, and that's all about implementation. So for the sake of implementation and going from a simple thing to a bit more challenging stuff, I put a simple synchronous function on the C++ side that we can write and get the value on JS side. So what does it say here? So everything that you see above those curly brackets basically generated for us. So Boolean type is linked to a bool. We have specified some strings, so they're being linked to a standard string of C++, and also we have a GSI runtime. Currently we don't need it, but we'll need it later. So it's always the first argument of the function, and the later comes all the arguments that you pass from the JS side. Just tell me if I go too quick, so I'll slow down. And what we are returning here is it's a bcrypt class that implements the hashing on C++ side, and we are just calling the validate password from that class and passing arguments that we are receiving from JS side. And we are just returning the result, so we don't need to do anything else to write a synchronous function. So things getting a bit more tricky when you are trying to write a promise, like some async code. But if we go through it once, I think you will get it pretty quickly. It's similar to the things that we do on JS side to create a promise. First thing we need to do, as you can see, is to extract promise class from the JS side. And that we can achieve by using GSI runtime. It has a function called getProperty as function, or it also has that getProperty function. So basically you can extract anything you want on a native side by using the GSI runtime. So you basically like able to write JS code even on native side. It's not required, but if you want, you can do it. And then we are calling that promise constructor just in the same way as we do as we create like promises on JavaScript side. We are just calling that constructor, passing a callback function with two arguments, which is resolve and reject. So the same thing happening here as this third, I guess, as a second parameter of the call as constructor function. So we are just passing a callback like we do on JS side, and it's called host function on the GSI side. Host function is basically a JavaScript function that you can, inside of it, you can write like C++ code. So if you are writing host functions, JS side will understand it without any issue. So it's like you're writing JS code, but instead you're using C++ syntax inside of it, and all its beauty. So when you're creating that host function, as always, you are passing that runtime as a first argument. Then next, you create some any ID, that's also some boilerplate. And then you are specifying the number of arguments. So the two here, as you can see, it's the number of arguments. As I said, it's resolve and reject functions that you want to access. And later, as the last argument, you are passing we call it inline function. It's called or anonymous function. Lambda expression is called on C++ world. So we are passing an inline function. The first, that brackets, it looks like a dependency array for React developers, but it's just capturing the context, getting the values that we are going to use inside our inline function. And here in the body, we are extracting the resolver function of promise by pointing to the first argument that we are receiving. And we again generate a hash, like calling just this bcrypt class. After generating a hash, we can call that resolve function that we extracted from the first argument and pass it to a JS side. I hope it's more or less clear. As I said, you just need to go through it 2-3 times. You'll be pretty familiar with it. And as a last point, here we will implement multithreading. I just didn't include that boilerplate code here for generating promise. So everything that you will see in the next slide is kind of this body of this promise constructor here. So this piece of code. So we changed that piece of code we slightly change it in a way that now we are also extracting the resolver function, but instead of running generate hash directly on our main thread, we are taking advantage of the thread constructors, thread class from the from the standard C++ library, and it accepts again a Lambda function that can be run on a separate thread. So anything you see inside of this Lambda expression is being run on a separate thread. So what we can run on separate thread, and the only thing we are not allowed to run on a separate thread is any GSI function. So any access to a runtime, any calls of the GSI. So basically GSI is thread safe, so you are not allowed to use it on some separate threads. So what we are exporting to a separate thread is that calculation of the hash. Basically, after calculating the hash on a separate thread, what we do, it's close. If you have developed any native code, you probably know it's there in Swift and Android. So you have on JSI side, you have this JS invoker, and it has a single method called invoke async. And anything written inside of its callback, of its constructor, makes sure that you'll be on a main thread. It means that, as I said previously, you cannot run GSI on any other thread. So we are taking that invoke async function and returning our value inside of it. So we are accessing the runtime only inside that invoke async function. And that's all here. So one more quick overview. We have a main thread. We are spawning a new thread. And the only thing we are exporting to a new thread is calculation of the hash, like generating of the hash. And we are not allowed to directly bypass, pass it to GS. Instead, we are just returning the value to a main thread, to a GSI, and then communicating back to GS. So I hope it's clear. It just caused so many segmentation faults and crashes for me during the development. So I just want to make sure that you are aware of it. And that's it. We are done with the development part, and we'll move to a demo. But before executing the code that we just wrote, I want to show you pure JS implementation of the hashing. So everything is happening on JS. And just want to point out the problem that we have there. So as you can see, in this demo app, I put that rectangle, and it indicates when the main thread is blocked. So as soon as we try to run the function on JavaScript side, the thread is blocked, and it's being blocked for around 15 up to 20 seconds, depending on your device. So it's pretty slow on JS. Now, if we move to our implementation and try to run the same thing with the same arguments on C++ side, as you can see, the first noticeable difference that this rectangle never stops. That means that our main thread is unblocked. And the other noticeable difference is the time taken for that calculation. As I said, everything is the same, but just the time is taken here less than half a second. So if we put it in a graph, you can see that the performance difference between the pure JS implementation and with the hacks that we did to bypass all these limitations. And yeah, that's pretty impressive, around like 50 times of increase in my old iPhone 12. So I put this slide prior to the last slide because I knew that there would be questions in your mind. So where does this thing even happening, like in real world scenarios? And I think it's pretty common. You just don't see it because it's being mainly implemented inside the libraries, like React Native Reanimated use this technique with their worklets to have that smooth animations. MMKV also use it, these host objects, to transfer data quickly. That's why, like Sebastian mentioned, there is a 30 times of increase in the performance. Also, I can point out Vision Camera, which use separate thread, generates a separate thread for each, like this frame processing. So if you check like the source code of these popular libraries, you will come up with something similar. It's not it's just a simple way of the things. Yeah, I think at this point we are good to move to the last slide. So thank you very much for your for listening. And there is a contact me QR code. Feel free to reach out to me. And there's also, it's my LinkedIn profile, but you can also find the GitHub repo there. So thank you very much, and I'm open to questions.